Hello friends, welcome to EPG Padasala. I am Dr. Karpagam Chinnammal from Chikana Government Arts and Science College, Tirupur. Today, we are going to deal with the topic auxiliaries for printing. What are auxiliaries? Most of the operations in textile processing such as covering, bleaching, dyeing, printing and finishing are carried out by the use of basic chemicals like acid, alkalis, oxidizing and reducing agents, dyestuffs, etc. In addition to this, other chemicals are also used in relatively small quantities to increase the efficiency of the above said processes. These substances are called textile auxiliaries. Auxiliaries help by speeding up the process or to carry out the process in a more efficient manner. They are necessary to obtain the desired effect. We have already seen about dyeing auxiliaries, and today we will deal with printing auxiliaries. In this session, we would get to know about the different printing auxiliaries and also learn the functions of printing auxiliaries. Printing auxiliaries. Textile printing is a process of applying color to fabric in definite pattern or design. Printing involves deposition of viscous paste containing the dye stuff, a thickening agent, a small amount of water and other printing assistants. It is immediately dried to prevent the spreading of the color beyond the boundaries of the design. The actual transfer of the dye stuff from the thickener film into the fiber of the fabric is carried out by steaming, curing or sometimes chemical fixation. What are these printing auxiliaries? The chemicals added to printing paste that facilitate production of effective and quality printing are called printing auxiliaries. There are different printing auxiliaries. They are classified according to their functions and various uses. The auxiliaries are selected based on the method of printing, dye class, fabric to be printed and compatibility with other ingredients in the paste. Some typical printing auxiliaries are briefly discussed below. Let us deal with each auxiliary in detail. First is dyestuffs and pigments. According to the fabric content, that is natural or synthetic, fastness property required for the printed fabric, dyes are selected from different classes of dye, that is acid, basic, cationic, direct, disperse, reactive, sulfur, vat, etc. For example, reactive for cotton, disperse for polyester and acid for wool and silk. Then there are pigments which can be applied to any fiber. Dyes are used in printing for two purposes. One, to color the printed area, that is direct style, and secondly to color the ground fabric and then to print with discharging agents, that is discharging style. In discharging style, the dye used for dyeing the ground material should be easily dischargeable. Next is binders or fixtures. In pigment printing, insoluble pigments which have no affinity for fibers have to be fixed onto the fiber with binders. Binders are polymeric film which holds a pigment on one hand and the textile substrate on the other. In other words, the pigment is embedded in the polymeric film of the binder which has adhesion to the fiber surface. Pigments have no groups which can react with the fiber. Fastness property of the pigment print therefore depends on the forces of adhesion between the fiber surface and the binder. Binders form a thin film on the printed portion and they must be colorless and clear. The sharpness and quality of the print depends on the binder's quality. Good binders should provide quality such as even thickness, smooth, elasticity, adhesion to substrate, resistance to chemical and physical stress, and lastly, easily removable after steaming. Fixtures are substances like binders which help in achieving optimum fastness properties. Prints of good fastness property on cellulosic fibers can be achieved using binders, fixtures such as melamine formaldehyde, vinyl resins, urea formaldehyde precondensates, chlorinated rubber and acrylic resins. The latest chemicals used are acramin and Lutexol HT. Acrylic binders can affect crocking fastness, color yield, handle and print appearance. Thickening agents. Thickeners, as its name implies, are mainly employed in giving consistency to coloring matter. Thickeners are high molecular weight compounds giving viscous paste in water. They impart stickiness and plasticity. Viscosity of printing paste is very important as it influences the clarity and appearance of the printed pattern. The viscosity should be stable not only during printing on machine but also while storing for weeks. The main function of thickener is to act as a vehicle for carrying the dye onto the cloth and to prevent the spreading of the color on the cloth by capillary action beyond the limits of the defined portion in the pattern. The adhesive nature of the thickener holds the dye particles during steaming. Fabric becomes saturated with steam and the chemical reactions take place. The soluble dye in the thickener gets absorbed by the fabric, giving the dye good fastness property. The thickener film containing dyes and chemicals should not be dried with too much of heat, which will lead to color mark off on the fabric. Thickeners should not turn into brittle flakes when cured by steaming. Essential characteristics required of thickeners are easy after wash. The unexhausted dyes and other byproducts present on the fabric should be removed from the fabric without staining the ground and affecting the other colors. It must retain the sharp outline of print, that is, avoid spreading of color beyond the outline of the design while curing or steaming. All thickeners should not react or get precipitated by the action of chemical, dyes, pigments which are added to printing paste. Thickeners are classified as natural, modified natural, synthetic and emulsion type. Natural thickener. These are of natural origin, widely distributed throughout the plant kingdom. They are easily available and present in abundance. Since these are renewable, they can be sustainable raw materials for the textile industry. As the ingredients of natural thickeners are purely natural, they are non-allergic and non-toxic to our body and cause no health hazard. In the natural thickeners, the first one is starch. Starches are the most serviceable of thickeners. It's a vegetable substance manufactured from cereals and tubers such as rice, wheat, maize, potato, etc. It is insoluble in cold water. Starch has a property of swelling when heated with water to give a viscous paste. This glutinous mass readily absorbs and retains color, and it is therefore the very best thickener. The next one is plant exudates or gums. Several gums are used in printing as a thickening agent or binding agent by which color connects with fibers, the chief of which are gum arabic and gum tragacanth. Gum tragacanth is the most powerful of thickening agent. It is extracted from leguminous plant like Astragalus gummifier as a dried up exudate and is a natural gum. It is difficult to dissolve in cold water but readily melts in boiling water and gives a thick smooth paste. 4 to 5% gives a thick paste useful for printing. The gum when removed leaves the cloth soft. The gum is stable under mild alkaline but unstable in strong alkaline conditions. The next one is gum Senegal or gum arabic. This is the more useful, possessing the advantage over most other thickening agents of being soluble in cold water, but the cost of the gum restricts its use. It is mainly derived from trees of the Acacia genus. For printing paste, 30 to 50% of the gum is required. The gum is stable in strongly alkaline and strongly acidic condition. It is commonly used in block and screen printing. The third one is the roots and seeds. Under that, guar gum. This gum is cheaper than gum tragacanth and is obtained from the seed of the guar plant. It forms viscous colloidal solution when hydrated in cold water. It gives maximum viscosity at low temperatures, that is 25 to 40 degrees centigrade. It is compatible with dyes and chemicals. Its derivatives are used in printing synthetic fabric. The next is locust bean gum. Gum Getavo. It is derived from the seeds of locust bean of the carob tree. Seaweed. Among that, sodium alginate. It is sodium salt of alginic acid which is found in seaweeds. Small amount of sodium alginate is required in the printing paste. It solubilizes in cold as well as in hot water, has good wettability, so absorption of dye by fiber is excellent. It is used with most of the dyes and gives best results with reactive dyes. It can be washed easily from the fabric and leaves the fabric soft. The next type is a modified natural thickeners. Under that, the first one is starch derivatives, dextrin or British gum. It is degradation product of starch made by heating it with mineral acid such as nitric acid or roasting at 160 degrees centigrade till it becomes soluble in water completely. For 100 parts of printing paste, 20 to 50 parts dextrin is used. The second one is cellulose derivatives. Cellulose, which is normally very insoluble in water, by chemical modification produce valuable thickeners. The first one is methyl cellulose. Methyl cellulose ether is obtained from wood pulp or cotton linters. Ether is insoluble in the presence of alkali and boiling water but soluble in cold water. Its consistency is retained during storage. The next one is sodium carboxymethyl cellulose, commonly called as CMC. It's obtained by reacting monochloroacetic acid and cellulose. The thickener is stable to alkali and so can be used for printing with vat dyes. It can be easily washed from fabric. Gum derivatives. Indelka microgram is a modified guar gum which is resistant to acids and alkalis. The next is the synthetic thickeners. Synthetic thickening agents are molecular substances, generally copolymers of unsaturated organic acids such as acrylic and malic anhydride. They have the following properties: high degree of purity, rapid preparation of stock thickening, simple printing recipe, good running properties, optimum depth of shade and brilliance of prints, and excellent stability. Synthetic thickeners have the ability to produce prints with better smoothness, levelness and sharpness as compared to natural and modified thickeners and are suitable for photographic and multicolor prints. They are used as a substitute for emulsion thickening in pigment printing. Synthetic acrylic based polymers are grouped into two classes: alkali swellable or soluble emulsion, hydrophobically modified alkali swellable emulsions. Emulsion thickener. Emulsion thickening derives its viscosity from a dispersion of tiny droplets of one liquid in another with a dispersing agent. The two liquids must not mix or be soluble. With development of pigment colors, emulsion came into existence. And emulsions are also employed for dyes. Emulsions are available in disperse phase and dispersing medium. For printing textile material, oil and water type of emulsion is popularly used. Widely accepted is kerosene based emulsion. Alkyl phenol ethylene oxide condensates are also used. Choice of a thickener will depend upon the class of dye to be printed and the style of printing. For example, British gum and starch tragacan thickener for direct dye, British gum for vat, sodium alginate for disperse, and synthetic for reactive. Wetting agents. Wetting agent is used to obtain a smooth paste of the dye stuff without formation of any lumps, which, if allowed to remain, get deposited on the cloth during printing, producing dark spots. It's used to dissolve the dye powder. It's not required in case of water soluble dyes. In case of insoluble dyes like naphthol and vat, wetting agents are used to facilitate wetting of the dyes and its subsequent dissolution. Turkey red oil, monopole soap, castellan oil are few examples of wetting agent. Turkey red oil is a commonly used agent. The next auxiliary is acids. The acids are used when acidic condition is required during steaming or curing to fix the color on the fabric. The acids are not required while printing but required during the steaming, so such acids which liberate during steaming should be used. The acids are required for the development of some class of dye and also to activate oxidizing agent during steaming or curing. For this purpose, two types of acid liberating agents are used. Firstly, organic and inorganic salts of ammonium salts such as oxalate, chloride, ammonium acetate, sulfate, nitrate, phosphate, etc. Ammonium chloride and diammonium hydrogen phosphate are examples. Secondly, esters of organic acid such as diethyl tartarate, which on heating splits into tartaric acid and ethyl alcohol. Tartaric acid will produce required amount of acidity. To prepare printing paste with reactive dye, free acids can be added such as formic, acetic, glycolic, tartaric, lactic and citric acids. Next auxiliary is alkalis. Alkalis like sodium carbonate, sodium bicarbonate and sodium silicate are necessary for fixing reactive colors in printing. While preparing printing paste, If strong alkalis are required, then sodium hydroxide and potassium hydroxide are preferred. For mild alkalis, sodium silicate, sodium and potassium carbonate, trisodium phosphate, triethanolamine, disodium phosphate, trisodium phosphate, ammonium hydroxide, etc. can be used. Sodium acetate is a salt of acetic acid and sodium hydroxide is a strong base. When sodium acetate is dissolved in water, it forms little amount of sodium hydroxide. If excess amount of acetic acid is added, neutralizing of alkali takes place and the solution becomes acidic. When the solution is boiled or the printed fabric is steamed, the acetic acid being volatile evaporates and wet thickener will acquire alkaline property. Hygroscopic agents. Hygroscopic agents are added in printing paste to enhance the transfer of the dye or pigment from the thickener film to fabric and facilitate subsequent washing of the thickener. Hygroscopic agents are especially used for printing class of dye like vat dyes. These are used to absorb sufficient amount of water during steaming and enable the dye molecules to diffuse into the fiber, thereby resulting in good color yield. Commonly used hygroscopic agents are glycerin, urea, sodium lactate, diethylene glycol, a 40 to 60 mixture of urea and formamide. Oxidizing agent. To develop final color during steaming or in developing dye baths in case of solubilized vat dyes and aniline black, oxidizing agents are required to be added. Some of the oxidizing agents are chlorates, nitrates, nitrites and potassium ferrocyanide. The oxidizing agent should be inactive at room temperature, that is 25 to 30 degrees centigrade. Oxidizing agents like sodium chlorate, potassium chlorate, etc. do not act in neutral or alkaline solution, so they are added with volatile base ammonia. The paste also contains acid liberating agents such as ammonium chloride, ammonium phosphate, etc. While steaming at 100 degrees centigrade, ammonia volatilizes and ammonium salt decomposes into acid and ammonia. Ammonia escapes, leaving behind acid, achieves chlorate at high temperatures and create oxidizing condition and color gets developed. Reducing agent. In discharge printing, reducing agents are used as discharging agents to chemically destruct the dye and create a white pattern on a colored background. The liberated hydrogen obtained by the decomposition of discharging agent during steaming process causes the decomposition of dischargeable dye into colorless water-soluble products which are removed in subsequent washing off process after printing, producing white effect on dyed fabric. The reducing agents such as Rangolite C, thiourea dioxide are helpful as reducing agents for discharge style printing. Formaldehyde sulfoxylate is one of the most powerful discharging agent. However, it is toxic and produces formaldehyde. Sodium borohydride has also been tried as an alternative. Zinc sulfoxylate formaldehyde is slightly soluble in water. This is used to discharge printing of polyester and is mainly suited for dispersed dye printing paste. For this purpose, stannous chloride, stannous acetate is also used. For vat printing, sodium hydrosulfite is used. Defoamers or anti-foaming agents. In case of roller printing, the use of a wetting agent in the printing paste coupled with continuous agitation of the paste in the color box during printing produces foam, which leads to defects in printing like lighter shade. So, to avoid faulty printing, defoaming agents are used. Defoamers such as silicon defoamers, octyl alcohol, turpentine, emulsifiable hydrocarbons, etc. can be used. Silicolabs and Perminal HBI are commercial products. Carriers. The carriers are organic compounds used for dyeing polyester because they increase the rate of dyeing. By incorporating carriers, deep shades can be achieved in polyester at 100 degrees centigrade. Without carriers, the deep shades cannot be obtained. Carriers cause swelling of the fiber and allow big molecules to diffuse faster into the fiber. Some of the carriers used are methyl salicylate or phenylphenol, monochloro or phenylphenol, diphenyl P phenylphenol and butyl benzoate. Solvents and dispersing agents. After an extent, water soluble compounds are not soluble in water. At a particular concentration, compounds are soluble, and further addition of compound does not dissolve in water, it settles down in the bottom. This is known as saturated solution compound in water. If temperature is raised, the water dissolves some more compounds and solution is saturated at low temperatures. At each temperature, there is saturation or solubility compound above which solution cannot dissolve. To increase the solubility of dye, certain solvents and solution are added. In printing paste, only a limited amount of water has to be used in which dyes reach saturation. In such cases, certain solvents are used to increase the solubility of the dyes and prevent agglomeration of the dye stuff in the highly concentrated paste. Acetone diethylene glycol, thiodiethylene glycol, etc. are commonly used solvents. After washing agents, the printed fabric after steaming has to be washed with soap solution. Washing with the soap solution makes the fabric soft, that is, soap will remove the thickener. It helps to achieve true color for some dyes. The miscellaneous auxiliaries are mordants. The mordants are used on cotton to print with basic dyes because basic dyes and cotton do not have affinity for each other, but mordants have affinity for both the fiber and the dye. The commonly used mordant is tannic acid, as cotton readily absorbs this acid and colors are also attracted to it. Leukotrop W, dimethylphenylbenzyl ammonium chloride, is used for discharging printing of wad dye. It forms a complex with leuco wad dye. It does not get oxidized when the oxidation of the wad dye takes place, so it can be easily washed and discharge can be obtained. Mild oxidants, ludigol or resist salt, are used as mild oxidants on direct dye in ground fabric printing with wad discharge. This substance saves the unprinted ground fabric from damage while steaming. Usually, the ludigol is used in the direct dye liquor. Sequestering agents are intended for blocking the activities of metallic ions present in the printing paste. Its recommended amount is 0.5% on weight of the paste. Example, sodium hexametaphosphate. Preservatives. When thickening paste is preserved for a long time, it may be spoiled by the action of bacteria and its viscosity may get lower. So, preservatives like salicylic acid, phenol, cresol, sodium benzoate, etc. can be used to prevent this. So, now that we have dealt with textile printing, let's just summarize it. Textile printing is the most versatile and a common method used for decorating of any textile fabric. The technology of printing along with dyeing has been the mainstay of textiles. In this module, we got an insight into the printing auxiliaries and their role in printing. Textile auxiliaries play a vital role in the final outcome of a good quality printed product. Hope you enjoyed the session and bye for now.